So, just a recap from what you should have gotten yesterday was we went over 8-man. So, we do know that our atomic number is going to be equal to the number of protons. This right here is your one guarantee no matter what. Your atomic number is equal to your protons. Most of the time, it's going to be equal to your electrons as well if it is called electrically neutral. Electrically neutral, okay? So this is when it's neutral. We will kind of see that today in our notes. We also went over mass number minus your atomic number is equal to your number of neutrons. Or in a shorter version, you have your mass number is a counting number, so it's a whole number, and it's going to be the number of protons plus the number of neutrons. So keep that in mind today. One more thing, if you focus in, so you should have gotten a copy of this periodic table on Schoology. And so if you kind of look at the setup that you've got here, just so you know what these numbers are called. So you have on your periodic table, you have your atomic number is going to be the number at the top, okay, or it might be on the bottom, but it's a big whole number, okay, and these numbers are very specific to each element. Every element has a unique atomic number, which represents the number of protons inside the nucleus. Then you have your chemical symbol. And then you have an average atomic mass. And we're going to see today and tomorrow that this is different than your mass number. An average atomic mass is going to be a weighted mass. And then there is your chemical name. So that leads us to nuclear notation, which is something that you'll start using. So if you think back over to the periodic table, if you have yours next to you, you know that this right here, this is lithium. Okay, so this is lithium. This number down here is your atomic number. You notice that the lithium on your periodic table has a 3 above it. So that is your atomic number. It has 3 protons inside that nucleus. This 7 up here, this is your mass number. So we're going to see that a mass number is going to be specific to different isotopes. Okay, so when we're going to be writing these names, we can say this is going to be lithium 7. We also see that we have a charge sometimes show up, and we're going to see that this is going to refer to if it is an ion or not, and what type of ion. So ions. Ions are going to show up, and we're going to go over these notes, when different numbers of electrons than protons. So your electrons are your negatively charged subatomic particles. Your protons are positively charged. So if you have an imbalance of those, then your element is an ion, okay? And it's going to be shown with a charge symbol, okay? Just like we saw above, that little positive sign. All right, an isotope is when we have different number of neutrons. And it's not in comparison to anything, because you can have different number of neutrons from protons and electrons. But what you're looking at is that there's going to be different isotopes that have different masses because they have this different number of neutrons. And so this is going to be shown by a chemical name, a dash, and then a mass number. Okay, just like you saw with our lithium example up here. You can also use the chemical symbol with a dash and again the number. Okay? All right. So now what we're going to do, kind of look at a couple of these notes. So let's start with ions. So ions, there's 2 different types of ions, okay? And I've kind of given you 2 examples right here. So we've got lithium. We notice there's a positive symbol. We have, this is oxygen. We notice it has a negative symbol and it's 2, minus 2. So if you notice, we have positively charged ions and we have negatively charged ions. So positively charged ones are called cations and negatively charged ones are called anions. An easy way to remember that is that a cation has a T in the middle, which looks like a positive sign. Anion has an N in the middle, which should remind you of a negative charge. So, what is this definition? So we have an electrically neutral atom has an equal number of positive and negative charges. So for example, if I have 2 positive charges, 2 negative charges, we have positive 2 plus a negative 2. So in math class, if we have a positive 2 plus a negative 2, we're going to have that equals 0. That's what we call electrically neutral, or it makes it neutral. So when the sum of the charges cancel each other out and they equal to 0, that's neutral. When you have an ion, that means that we're going to be gaining or losing 1 or more electrons. So notice, it has nothing to do with the protons changing. The only thing that is changed in your elements, okay, are going to be the number of electrons. Those things are sitting on the outside of that nucleus. They're easily removed or added to. So electrons are going to be the reason that we end up getting this electrical charge. Okay, so if we have more electrons than we do protons, then that means that it is negatively charged. If we have less electrons than protons, meaning we've lost an electron or 2, then we're going to have a positive charge. Okay? Neutrons are not affecting this. So here's another slide that's just going to reiterate what I just said. So I'll let you read that on your own. Okay, so a couple examples. This will look very similar to what your homework is. So for these examples, we notice that we have little chemical symbols. Okay, so let's start with the first one. We have Cl. So we're going to find Cl somewhere on our periodic table. It's right here. So that's chlorine. So it wants to know, so I would write these out so that you get some practice with that. And this is going to be a chlorine. And I want you to practice saying whether it's an anion or a cation. So this one, if you notice, has a negative symbol. So remember, we have anion, remember that N, and we have cation, remember the positive symbol in the middle. So this one is negative, so this is an anion. Okay? So your number of protons is going to be your atomic number. So chlorine, if we zoom back in again, has an atomic number of 17. So we're going to go ahead and write 17 protons. Number of electrons. So if this is an anion and it has a -1 charge, what we're asking ourselves is, okay, so if I have 17 protons, I need it to be more negative. Do we want a bigger number of electrons or a smaller amount of electrons? The answer is we want a bigger number of electrons. So we could have 18 electrons. So if we have 17 protons, 18 electrons, you're really looking at it being 17 plus a -18 would give you a -1. So it's a little bit of algebra class kicking in now, okay? So number of electrons is going to be 18. The idea is that your number of electrons was greater than your number of protons to get you that number. All right, for the next one, we have Mg with a +2 symbol. So Mg is right here. This is magnesium. You do see that it has a plus sign. So we're going to go a +2. So we'll go ahead and label this one as a magnesium cation. Your magnesium has an atomic number of 12. So again, your atomic number is your number of protons. We need it to be a +2 charge. So we're going to look at it the same way. If I have 12 protons, we want to have 2 more of the protons than of the electrons. So what we can say is that we have 10 electrons, right? So if we have more protons than we do electrons, that gives us that positive charge, and this will give us a positive 2 charge. And that would be the answer for that. Okay, moving us along. Isotopes. So isotopes are going to be the ones, if you remember from the first slide, that we're messing with the different amounts of mass. So neutrons don't have a charge. They're not positive, they're not negative. They just carry a mass, and that gives these different, I like to think of it as the different flavors of these elements, because all that it really is, they're still what they are. They just have a little different mass, okay? And so so basically that's what we're working with here. And these isotopes occur naturally, and so we kind of analyze those things to come up with those fancy average atomic masses. And it's going to be taking into account how often is that flavor of this element showing up versus another one. Okay, so we're just looking at the neutrons, so no charges. All right, so just to kind of emphasize what I just said, remember that it has to do with your same number of protons, different number of neutrons. This is not comparing each other. We're not comparing the neutrons to the protons. We're just saying there's different numbers of neutrons in each type. Okay, and that's how they're labeled. So then we see this bullet point number 2, where it says the average atomic mass is found by calculating the weighted average of the atomic masses of the naturally occurring isotopes. So we will have a lab over that, but I want you to think of that. So if it's a weighted average, it's just like calculating grades. So we have summative assignments, so your tests and stuff, those are weighted 40%, your labs are weighted 40%, and your daily grades are only 20%, meaning you can get 100 on all your daily grades, but if you bomb all your tests, it's not going to show that you have 100% average. It only accounts for 20% of the grade versus your tests and stuff accounting for 40%. And that's where that average atomic mass will come from, but we'll have a whole lab over that. All right. So this is just kind of going over a few of the definitions. You can look at that on your own again. Okay, so isotopes. So let's get a little bit of practice with this. And these are specific isotopes. These guys have fancy names because they're the hydrogen ones. Not all of them have that. We are looking at more of this notation. Sorry, it's hyphen notation, which is you have your chemical symbol, a little hyphen, and then your isotope or your mass number, okay? So this is hydrogen 1. What that means, this is your mass number. Hydrogen has an atomic number, so all these are about hydrogen. Hydrogen has an atomic number of 1. So that means we have 1 proton for all of these. When we're talking about the neutrons, we're going to be paying attention now to our mass numbers. So remember, your neutrons are going to come from your mass number minus your atomic number. Okay? So your mass number is 1 minus your atomic number of 1. So really, the protium, or hydrogen 1, doesn't have any neutrons. It's just the proton that's accounting for most of its weight. For the deuterium, or hydrogen 2, we have a mass number of 2, so we're going to have 2 minus 1 to give us 1 neutron. This one has 1 minus 1, I gave a 0. Okay, and then finally we have our tritium, which is hydrogen 3, so we have 3 minus 1 to give us 2. Okay, so you can kind of see what the neutrons are looking like. And remember, it's coming from mass numbers minus atomic numbers. And these mass numbers you can find in this hyphen notation. It's always the number that's after the little dash. All right, number of electrons. So if we look at these, Are there any charges? And if you look at them, no, there is no charges. So electrons are going to be equal to your protons. So therefore it's 1, 1, 1. Okay, so now we're going to practice a couple more that aren't hydrogen. And so we've got carbon 14. So I'm just going to go ahead and move this circle over here to find carbon. So we have carbon 14. So this right here is showing you an isotope. Okay, so we have carbon. The atomic number of carbon is going to be 6. So I'm going to put the symbol first. So C for carbon. Atomic number is 6. And this number right here is your isotope number, or your mass number, I'm sorry. So we're going to put 14 up here. There are no charges on this one. It's not representing anything. It's not saying cation or anion, so we leave it like that. Uranium, 232. So let's find uranium. Uranium's right here. And so what we've got is we've got U, and we've got 92 is our atomic number. And remember, you're not guessing about this mass number. It's given to you right in the name. I have to give that information to you, okay? So you would have 92 down below, 232 above. And then for this one, this is just showing you the nuclear notation, and I want you to write the hyphen notation. So so basically you're naming the isotope, right? So we have Na. So if you look on your periodic table, Na is sodium. So we're going to write sodium. Remember, this 11 is just coming from the atomic number. We don't have to say anything about that because we're putting the name. So we have sodium. We're going to put a dash, but we're going to include this mass number, and we're going to say 20. So this is sodium 20, isotope sodium 20. All right, so you guys are now going to be knocking this out. When you open this document, you see all the colored blocks. The colored blocks is where you will just tap the screen right there, and then you should be able to write in the box, okay? So a couple things I want to point out. So this isotope name, you kind of see that we've got this going on. So how are you going to figure it out for ones that I'm not giving you the symbol at all? You go to your atomic number. Look up who number 26 is right here. That one's going to be iron, okay? Look up who is Au. Au right here, so that is gold, okay? So make sure you're using your periodic table, and yeah. Underneath, oh, and I also would like you to, if you can fit it in the square off on the side or in the comments underneath your slide, tell me, how are you solving for these? Okay, so just give a little, so remember, your nuclear symbol is just what we were just now practicing, atomic number. You should be getting it straight from your periodic table. Don't guess on that. Your mass number should be given from your number of protons, from protons plus neutrons. So really, it should be coming from your atomic number and any kind of mass number given to you, right? Okay. And then right here, you see that you do have an ion. So look at how many electrons extra that you have. Down here, these are all ions. So I do want you to be paying attention to how does your protons and electrons compare. Protons, again, this is your atomic number. So grab your atomic number from your periodic table. Let me know if you need any help.